Okay, so chapter 7 is about polygons. What is a polygon? It is a shape. That's it, right? It's made up of straight lines, so is a circle a polygon? We're going to talk about the inside angles and the outside angles. Today we're doing inside, tomorrow we're doing outside. So, we're going to start with this. In a polygon, you have a fill in the blank. In a polygon, two vertices that are endpoints of the same side are called consecutive vertices. So pick a letter, any letter that's on this polygon. E. What is E consecutive with? E consecutive means it is on the same side. So EA and ED. So the reason this is important is we're going to be drawing diagonals, and a diagonal of a polygon is a segment that connects two non-consecutive vertices. Why does that matter? We're going to be finding out how many degrees fit inside of any polygon. And to do that, we're going to draw diagonals. You picked E, right? EA is not a diagonal. Is EB a diagonal? Yes. Is EC a diagonal? Yes. Is ED a diagonal? No. So the reason this matters, what did I just split this shape into? Triangles. What do you know about the angles in a triangle? They equaled 180. So how many triangles are there? There's 3. So there's 180 degrees, 180 degrees, 180 degrees. So how many degrees fit inside of this figure? 180 plus 180 plus 180, which is... This is why you need your calculator. 540 degrees. So basically in this section, we're figuring out how many triangles fit inside of a figure, and then that's how we know how many degrees are. So we got a triangle. What do we call a 4-sided figure? Quadrilateral. 5-sided figure? Pentagon. 6-sided figure? Hexagon. So you're going to fill in this chart with me. How many sides does a triangle have? 3. Then it says number of triangles. So just like before, we would see if we could draw a diagonal to split this triangle into more triangles. Can you draw a diagonal from this vertex to another vertex? No. So how many triangles are in a triangle? Just the one. So the sum, so what all of these interior angles add up to is a sum. The sum of the angles, there's one triangle. Each triangle is 180 degrees. So there's 180 degrees in a triangle. I know you're like, that's dumb. We're going to talk about it in bigger polygons. In a quadrilateral, how many sides are there? 4. Pick one of the vertices. So top left, top right, bottom left, bottom right. Bottom right. How many diagonals can I draw from the bottom right? 1. And this splits, beautiful. And this splits the quadrilateral into 2 triangles. So knowing this, there's 2 triangles, and each triangle is 180 degrees. So how many degrees fit inside of a quadrilateral? 360. All right, a pentagon. Pick one of the vertices. Top left. There's not really a... Is that what you meant? Yeah. Okay. I can draw a diagonal here and a diagonal here. So it splits this into how many triangles? 3. So pentagon has 5 sides. It has 3 triangles in it. So 3 times 180 is 540. And then last is a hexagon. Pick a vertex. Bottom right. So a diagonal here, here, and here. How many triangles does this split a hexagon into? 4. So it has 6 sides, 4 triangles. So 4 triangles times 180 degrees is 720. You're close. So this is where a formula comes in, and this is where it comes from. What is the relationship between the number of sides and the number of triangles? Yeah, the number of triangles is 2 less than the number of sides. So n represents the number of sides. To find the number of triangles, you're going to do the number of sides minus 2. So then the sum is going to be n minus 2 times 180. So n minus 2 tells me how many triangles there are, and each triangle is 180 degrees. I would take your highlighter and just highlight this box because it's the most important part of this lesson. N minus 2 times 180. So the only reason that students find this part hard is because they don't know when to apply it, because the instructions are really long. It looks like this. There's a bunch of prepositions. Do y'all know what a preposition is? Whatever. It's fine. English. It's fine. Find the sum of the measures of the interior angles of the indicated convex polygon. It means tell me what all of the angles inside add up to. So I want you to highlight these instructions because this is what you're going to see. Quizzes and tests, just that's the way it comes. So I would highlight it with a highlighter. Are you just lazy or you don't have one? No? Okay. So number 1, we have an octagon. So to find how many degrees fit inside of an octagon, we're going to use the formula. N minus 2 times 180. N represents the number of sides. How many sides does an octagon have? 8. So how many triangles are in an octagon? 6. Remember that, yeah. 6 times 180. It is
860. 880.
Connor, please stop yelling at random numbers. On a normal day, I wouldn't care so much, but 1080. 1080, yeah. Alright, that's it. That's the formula. Ready? 15 gone. So n minus 2 times 180. Number of sides is 15. How many triangles are in a 15 gone? 13 times 180. 2,340 degrees. You're going to do the last column. The last question. Yeah. It goes all the way up to a 96 gone. Let's circle. The more sides there are, what do you mean?
97.
It looks like a circle. So the more sides there are, the closer they are. Wonderful. So how many triangles are in a 24-sided polygon? 22 times 180 is?
3960.
Wonderful. Go ahead and flip when you're ready. I'm not going to change the page because you're going to fill in a chart first. So what's going to happen, the last thing we learned today, instead of being given the name and finding the degrees, we're going to be given the degrees and find the name. So in order to do that, you need to know the names. So as a refresher, at the top is a chart, the number of sides, and the name. So 3-sided polygon is called triangle. 4-sided is called a quadrilateral. Quadrilateral. 5-sided polygon. Pentagon. Pentagon. P-E-N-T-A. Gone. 6-sided. Hexagon. 7-sided. Heptagon. 8-sided. Octagon. 9-sided. Nonagon. N-O-N-A. Gone. 10-sided. Decagon. 11-sided. Hendecagon. H-E-N. Decagon. And then 12-sided. Dodecagon. So you're only required through 12, but if you knew 13 and above, you get bonus points on your quiz. So if you had a question that ended up with 15 gone as the polygon, any of the 10s end in decagon, you just need to know the prefix. So that's why 12 is dodecagon, 13, what is a prefix for 3? Tri. So tridecagon. 14 is weird as tetra, but that's the only one. Tetradecagon. So I think of like Tetris. 15 is 5. What is the prefix? Pentadecagon. And 6 would be hexadecagon. 7 would be heptadecagon. 8 would be octadecagon. And 9 would be nonadecagon. After that, it's called a cosagon for the 20s. The person that memorized the most, actually, Lily, was your brother.
Of course it is.
Like through number 30. I had to look them up as he.
Special.
Yeah, but it's okay. But anyways, the more that you do, on quizzes and tests, I just give you bonus points for knowing how to name it. Well, through 12, you definitely should already know.
I know those.
Okay. All right, so this time we're going to do the opposite. They gave us the sum of the measures of the interior angles of a polygon. We need to classify the polygon by the number of sides. So the best way to look at it is this formula equaled the sum of the angles. So we're given the sum of the angles, so we're going to like plug it in without writing down the all that word. We're getting there. Look at you, Connor. So 900 degrees equals n minus 2 times 180.
Couldn't you do n plus 2 divided by 180?
No. Yes, but no. Not the way you're saying it, but I understand what you're saying. You can do it in your head. That's what we're about to do. Just in a different order. Don't add 2 first. The first thing we want to do is get rid of that 180, so we need to you can distribute if you want to. You're just going to get bigger numbers. You're going to end up with 360. Yeah, that'd be ugly. It's not wrong. But I'll address what you were asking in a second. So we divide by 180. What is 900 divided by 180? If you ever don't have a calculator and they both end in a 0, just take off a 0.
5.
Yes, 5. 5 equals n minus 2. So the last step is to add 2. So the number of sides is 7, which makes this heptagon. So to answer your question, Jace, I think what you're asking is, some people don't write it all out like this, which is fine. They just divide by 180, and then usually people mess up here. So as long as you know you divide and then you have to add to the opposite action, it's fine. Because you're working your way backwards, right? So I'm fine with it. Just show me what you did. Number 5, we do the same thing. Plug in 1620 equals n minus 2 times 180. Divide by 180. Which is, sounds good. All right, then add 2. And we get 11, which is a hendecagon. So make sure you actually classify it like the directions say. You're going to do the last one, and then we are done. Depending on how quickly you get through it. You finished it before the 7. All right, you got to classify it. Ooh, what's what? I would retype it in.
Right there.
Yeah. Before that. I don't know. Before the adding 2. That's pretty good.
Huh?
But at least you know the steps.
Well, okay, so you're technically dividing things by
18.
Sometimes I wish I could do dovetailing on my mouse.
Isn't 18 gone?
So,
What am I supposed
the
to
only
say?
thing that helps me is that I can give you that you can type something around. I would know.
Would it just be 18 gone?
Yes.
Yeah, so make sure you classify, Jason. Alright, so divide by 180, add 2, and you get 18 gone, or you can say octadecagon.